Welcome to another Simple Engineering Snippet. In this instructional video, we determine the dimensionality of a provided flow field, determine the equation for the streamlines, and the velocity at a point. I hope you find it instructive. The velocity vector for the flow field is equal to AXI minus AYJ, where I and J denote the unit vectors in the X and Y directions, respectively. Let's review what a 1D, 2D, or 3D flow field means. A flow is classified 1, 2, or 3-dimensional depending on the number of space coordinates required to specify the velocity field. There are alternative definitions that account on how fluid properties, i.e. density, varies, but the above is the most used definition. The provided flow field is a 2-dimensional flow. Let's break it down into the component velocities and set the constant A equal to 0.25 and plot at the point x equals 5, y equals 5. Now let's add to the plot the actual velocity vector v. One point isn't very interesting or revealing. Let's plot more velocities in the xy plane. This is a bit more illustrative. It looks like the flow is coming down from the positive y direction and then turning into the positive x direction. Now let's proceed to part B and determine the equation for the streamlines. Let's review how streamlines are defined. Streamlines are drawn in the flow field so that any given instant they are tangent to the direction of flow at every point in the flow field. Using the definition of a streamline, we obtain that dy dx is equal to minus y over x. We now integrate this expression to obtain the equation xy equals c, where c is a constant. Each constant represents a streamline. In our previous example, we plotted the velocity components at the point xy equals 5, 5. The constant for this point is 5 times 5, or 25. For the last step, we plug in coordinate values into the velocity equation to obtain the x and y component of velocities as shown. I hope you found this instructional video useful. If so, then please like and subscribe. Thanks, and have a great day.